Where'd you come from? Hey, Jeffrey, how'd you get out of Greymar?
He can go wherever he pleases because he has the magical animal.
Yeah, I'm seeing that.
Powers.
Somehow he broke out of Greymar.
I think he died and his twin took over for him and found James to support him through that loss.
Definitely. Jeffrey shrunk.
Okay, funny. All right, if you have not gone to Nearpod, if you'll go to join.nearpod.com and put in that code, and you should see the code on the screen there, and take a stab at that drawing about its volume. And I've hidden the names, and as you see one that's submitted, see what you think about what they've done. Let me see if I can click on them. So there's one. So here's what I'd like for you to do right now. If you have not gone to join.nearpod.com and put in QLEVR, you should have a little drawing tool. And I'm putting this drawing tool up because I think it's a little better than the Pear Deck drawing. But we'll go back to Pear Deck in just a minute because today we're going to talk about these kind of shapes, which if you watch the Ed Puzzle, it talked about them in the Ed Puzzle this morning.
Mr. Can you click out of the little picture? I can't see the code.
Yeah. It's QLEVR. QLEVR. On your Zoom, if you can make sure that your name is there, like somebody just says iPhone, because that makes it easier for me to know who's there. But everybody else, I can tell who it is. So if whoever's on iPhone could just put your nickname or put your name, if you could.
Can you help clean up the room? No.
All right, several of you are submitting now, so move this over a little bit. Okay, so I'm going to click on a couple of the drawings, and let me give like 30 more seconds if you're still drawing, because this is a new kind of shape. Everybody okay there? All right, so I'm going to click on a few of these. I'm trying to pick the one I wanted to pick. And let's just see if we notice anything about it. I know who they are, but you can't tell who they are. So if you look at this one, and tell me some things you notice about it. So it says divide base 1 plus base 2 of the base to get its area, and divide that by 2 and then multiply it by the height. So would that be, could someone tell me where that is on the drawing? I see you. Would you tell us what part of the drawing is the base of the solid 3D? Ramita, could you tell us? You can't hear. Can you hear me? You're muted. I'm going to unmute you. It says you're muted.
Can you hear me?
Now, Permita.
The base is the trapezoid shape.
Yeah.
Right?
The base is this trapezoid right here. Can you all see my mouse moving?
Yeah.
Okay, so this is the trapezoid. Here's its matching trapezoid back here. Could someone else tell me if they see any issue with my drawing, with my shape? Is there anything that is a problem about my shape?
Yeah, you can't get the volume of it because you don't have the height of the trapezoid.
You are exactly right. You do not have the height of the trapezoid, okay? I purposely gave you this to see if you would fall for the trap. Do you see this 5 right here? That is not the height of the trapezoid. Kylie, can you tell us why that is not the height of the trapezoid base?
Because it's slanted, and so if you were to move this, straighten the slant up, it'd be taller than the actual height.
Correct. If I take this side that is 5 and I make it perpendicular to that 3 in the trapezoid, it would not fit this over here. Okay, this person put a question mark right there, and that's exactly right. I think that's a question mark. What if that person stuck a 5 right there? Would that be correct?
No.
No, that 5 would not be a correct height for this. Would it be more or less than 5?
Less.
Yeah, less than 5. Okay, so this might be 4.5. So we would need this to be able to answer that question. So let's just scroll through a couple of these and see what people said. All right. Here we got the person in purple. That's great. Saying the height of the solid is 8. But we got to get the base of the thing. And to get the base, they said, yep, base 1 plus base 2, half it times its height. Great drawing right there. Dr. Parsons is giving that one her stamp of approval because they figured out the exact lines they need. That's right. All right, let's see what happened right here. They realize, okay, look here. Great way to write this. This person watched the Edpuzzle video. So put a big 8 on the outside of the whole thing. That's the height of the solid. Inside the parentheses, let's do the 6. And we got the 6 up here plus the 3 down here. Add those times 5, except really it would be not times 5, but it'd be times this. Divide by 2. So that's correct. It just, the 5 is not the height, right? So I'm taking a snapshot of that one. All right. Look what this one says. We need to know this because we cannot do the problem. Anybody want to claim that one?
Me, Mr. P.
Okay, Graham, you're right. This little arrow here tells us that he was trying to trick you because that can't be done without this height here. This would be something if all this hadn't happened and you had TCAP, this I could envision this kind of question being on TCAP, where they're trying to make you fall for the distractor of that 5, which is not the height, because it is not perpendicular. Remember, it has to be perpendicular. Okay, let me go on to a couple more. And this person realizes that they got to get big B. Look at this. They realize big B is the area of the trapezoid times the height. Could someone tell me about this part right here? How is this one uniform for all of these prisms? Could someone tell me why this is uniform for all prisms?
Because
Go ahead. Wow. Could somebody, I don't know who it was talking, it was a girl.
so because you have to have the base of the actual shape, and then you have to multiply that by
the height. And again, like we said, I'm gonna yeah, thank you for mentioning that. So that's where in Mathland, I wish there were different words besides big B for the base of a solid versus anything by the base of a polygon, because it makes clear about that. But that's why that was important that on the first day we did just height. Area of the base with a big B times the height of the thing. Okay, I'm gonna mute everybody. And then just unmute yourself when you come in, okay? So that feedback will go away. Real quickly, moving on right here. This person, we said that one already. They realized that we need to know this over here. Let's see else what we got here. Whose is this?
That's mine. Sorry,
Okay.
it was a light color.
Tell us what you got there.
Okay, so I said we can't find the volume without this value,
Right.
because the height of the trapezoid is something you need to rely on.
So I could put an X there, couldn't I? And say that's
Yes.
my unknown. Yep, don't know it right now. All right, I think that I will close this out. So let's go ahead and switch over to the pair deck. So let me figure out how to get there. Okay, I need to share. Okay, let's see here. I need to share again, and I need to share. Where did it go? Dr. Parsons, you think you're funny, don't you? Oh, here it is. Okay, but where's the, okay. All right, let me find where the pair deck went. Did I trash it? Okay, here it is. All right. Guess I'll just say desktop. All right, so here's the pair deck. And volume number 3. So let me get to my phone here. Can you all see it says volume number 3? Okay, so let's quick do a fast review from Thursday of this. You all can see, right? The slide?
Yeah, we can see.
Okay. But is it got my whole laptop on it, or just it's got the whole thing on, doesn't it?
Yeah.
Which is fine. Okay. All right. So if you will tell me what is the volume of this triangular prism really quickly, and then we're going to move on.
Mr. P, what's the pair deck code?
Oh, the pair deck code is, hang on just a second. I got it in here somewhere, right here. It is CMAED. CMAED.
Oh, it was right there in the corner.
Oh, yeah, it is. I thought it was, but I didn't catch it. I didn't see it there. All right, so is it true that I'm going to say 9 times 12, which is 108 times 18? Is that correct? Or did I leave a missing piece out? Yeah, I left out a part. Yeah, I got to do 9 times 12, 108 in half, so 54, because it's a triangle. 54 times the height, which is 18, right? So that would be this. And then I get from that 972, right? Square centimeters? No. Cubic centimeters. That, right? All right. Yes. Okay. So moving on, I'm going to scoot through here really quickly. Just, you don't need to do this. I'm just going to review it real fast. Okay, on this one, the important parts are this is the height. So it's going to be times 15. And then I'm going to do 11 times 13, half of that. And half of that times the 15 will give me the volume. Okay, so I'm moving on. All right. On this one, really quickly, I would say 6 times 8 is 48 times 14. Is that right? Yes or no? Tell me yes or no on this, on your response. So 6 times 8 is 48. Half of that's 12. 12 times 14. Is that right? Just answer yes or no. Did I do it correctly? All of you are busting me. You're right. I did it wrong. It would be 8 times 14, half of that, because this is the triangular base, right? So you're correct. This is the base of this deal because it's about the triangle. So how many faces does this have? Will you text me the number of faces that this solid has? So I'm in the kitchen today because it's too cold out on the screen porch, and Dr. Parsons is giving me sass here. She thinks it's funny. All right, which it actually is. All right, so how many faces? Okay, somebody said, sorry, no, Mr. P. You're right, I was wrong on that. That's right, Pernita. No. I'm getting all kind of no's. Now tell me the number of faces. Okay, I'm getting 5. I'm getting 336. No, that was volume. So I'm getting a lot of 5s. That is correct. There are 5 faces. Okay, I'm going to point to the 5 faces. We can only see 2 of them, correct? All right. The ones we can't see are there's a face back behind here. There's a face back here. And there's a face up under here, right? Now, this face over here is the other triangle, right? This face back here is another rectangle that would look like this rectangle. What about the face down here underneath? Is that face going to match this face here? Answer to that's no. It's going to be a different, but it's a rectangle, but it's not going to be the same. But this face wouldn't match that face over there either, though, actually. None of those 3 rectangles are the same. But this front triangle face would match this triangle face back here. So a total of 5 faces is correct. All right, now let's move on to today's different shape, which is a trapezoidal prism. All right, on this page right here, will you send me a response to tell me what is a trapezoidal prism and what's necessary to solve it? Its volume. What is a trapezoidal prism and what is it necessary to do to solve it? By the way, regular 6th graders would not do trapezoidal prisms, but since you're magnet kids, you're doing it because that's the advanced piece of this, because you're in honors math. So you're pushing on to trapezoidal prisms because regular 6th graders would stop with triangular and rectangular. So let me see what you're saying on here. Do I have somebody who would volunteer to share out in just a minute when everybody gets a chance to finish writing? Just unmute yourself and say you will.
I will, Mr. P.
Okay, thank you. Josiah, I'm glad you're with us, though. Okay, how do I get that to go away? Don't want that there anymore. Go away. Oh, me, go away. Okay, now. this back down. Okay, over here. Okay, that's better. Okay. All right, so let's see here. I'm talking to myself. Okay, so most of you are ready. Okay, James, that's a pretty good little drawing you did there. I couldn't do that. Okay, lots of good responses. Okay, so Graham, will you unmute and tell us what you say is the necessary information to solve a trapezoidal prism, and what is it anyway?
You would need the formula to solve it, and I probably got this wrong since I get the formulas mixed up, but is it base times height divided by 2?
Okay, it's the two
Or am I
bases.
thinking of this? That's the triangle one, isn't it?
Yeah, it's the two bases of the actual base. So it's the two lines in the trapezoid.
Right.
So let me state it a different way. Here's a good way to think about it. In the trapezoid, it's the two parallel lines. So get the two parallel lines, take their two numbers, add them, half them. Then multiply that times the height of the trapezoid itself, and that's the area of the base of the solid.
So it's in parentheses base 1 plus base 2, right?
Yes.
And then don't you do you divide that?
You divide that by 2, yeah.
Yeah. Okay. And in the rectangle one, you don't divide it.
Right. So the trap, you're going to say base 1 plus base 2, and then you're going to divide that. Let me do this in parentheses. And you're going to take that and divide by 2. I can't make a divide sign. Divide that by 2, right? And then you're going to say all of that times its height. And then you're going to take that answer. Let me do this bigger. Whatever you get there for an answer, you're going to multiply the trap as your big B, the base of the solid. The trap's area is then the base of the solid. And then you're going to multiply that times the height of the solid, right? So that's correct. And by the way, what is a trapezoidal prism? What is a trapezoidal prism?
It's a prism that has the base is a trapezoid.
That is correct. It's a trapezoid that the base is, it's a solid that has a base as a trapezoid and has a matching trapezoid on the top, right? Now, does it literally have to be sitting on the base? No, like it didn't in the one we just did, right? All right, now, will you try this one? Wait, no. Okay, so here's the one we had a minute ago. So we're going to do it now, but I'm going to give you the actual height that wasn't there before, because I said what's wrong with it. It's missing the height of the base. So I'm going to give you that right here. And it is 4.5. I'll just make it 4. So you don't have to do a decimal. All right. Okay, so will you go ahead and let me know what you get for the answer? So there it is. I gave you the missing piece, which is the height of the trapezoid base, which is a 4. So if you'll just, in this space here, put in what the volume should be of this whole thing, please.
You guys stop. You're gonna break it.
It was the lighter color. The charcoal is black. No, it was not that.
White?
Something like that. It was the lighter one that had the more 3D effect.
Mr. P,
Yes.
is this in like centimeters, meters?
When you don't have a number, you just say units.
Oh, okay.
We can just let's call it feet.
Okay.
We're going to call it feet, so I'll type that in. Really? I think. So, what's 4.5 times 4? 18. So it's 18 for the area of the base, right? See, that's what y'all said. So then it's 18 times 8. Is that 144? So yep, you all are agreeing that it's 144. If you did not get 144 cubic feet there, do you see why it is? So for this bottom part here, I want to get this part here, all of this, and that's, I know, fill all that in, pretend like that's filled in. Okay, so you fill all this, you get this base down here, and that is 6 plus 3, half of that, which is 4.5, and then 4.5 times 4, which is 18, and then 18 times up here the height of the whole thing, which is the 144, right? Okay, so let me clear this and we'll do another one. Clear all drawings. Okay, here's another one. So this time you got to verify and then just tell me, is it F, G, H, or J? This will be something like you would see on a standardized test. Make 22, 77. 77 times 20. 77 times 20. Okay. Okay, most everybody is saying that the answer is G, 1,540 cubic inches. And you are correct. Would someone who has not talked be willing to tell us how we get G 1540? Love to hear from somebody I haven't heard from. Liam, Lincoln, Courtney, Madeline, Ashley, Izzy, anybody, whoever has the diamond as your picture. Michaela, you want to tell us about it?
Sure.
Okay, thank you, Michaela.
So I did 14 inches plus 8 inches, which is 22 inches. And then I did that times 7, which is 100, which is 154
Divided
inches
by 2.
by 2.
Yep.
And then I did, which was
77.
77.
Yep.
And then 77 times 20.
Wait,
which
why
was-
times 20?
Because that's the height.
That's the height of the whole thing. Yep. And then you get a volume of?
1,540 cubic inches.
Yes. Could someone tell me which one of those on there would be the easy trick answer? By the way, that I don't think anybody fell for it. I don't think anybody on here put it. 1. Most everybody got G, but which one would be, James, your hand's up. Thank you, James. Which one's the trick answer?
H, I think.
8. Why is H tricky?
Because it's half of G.
Okay. Yep.
No, it's G. G's tricky one. Because it's half of G. J.
Okay. So I think did you mean J is the tricky one?
Yes. Sorry.
Okay. J is the tricky one because that person who, if you picked a J, you forgot to half your trapezoid number, right? And you did 154 times 20 to get that 3,080. Because remember, it's 8 plus 14, which is 22, half of that, 11. 11 times 7, 77, 77 times 20, right? James, correct?
Mm-hmm.
Okay. Let's try another one before we run out of time here. Really quickly, while I'm telling you this, today we'll do GimKit right after this. Tomorrow, GimKit will be at 2 o'clock, and it will be the entire 6th grade in a battle with every homeroom. It'll rerun exactly the same way. It'll be on my Zoom. I'll send you the Zoom. I'll send you the GimKit, but they will all be able to join in too. And we'll see who can beat the entire 6th grade. So there could be like 100 people on there. So that's and then we'll do that. Hang on just a second. We'll do that on tomorrow in math with Miss Profader and Miss Boersma. We'll do it again on Wednesday at 2 o'clock with Miss Schaefer and Miss Quinn, a 6th grade battle. And then on Friday, the GimKit battle is going to be parents versus students. So you got to get your parents at 11. So the 6th grade battles will be at 2 p.m. tomorrow and Wednesday. Today's GimKit's right after this. Friday's GimKit will be right after this as well, but we want parents to be on, we'll do 2 teams, have all the parents on a team, and then put all the kids on a team. So we want to do that tomorrow, Friday. Okay, so be asking your parents if Friday at 11:30 they'd be free to play GimKit on their phone. And they don't have to have an account. They just go to the GimKit join place and put in the code. And then you all can like beat them. Wouldn't that be? Here's what you do. Also, make some kind of deal that if the kids win, that they have to like get you something or let you out of a chore or something on Friday.
What's the GimKit on today?
The GimKit on today is science.
Okay.
All right.
So Friday birthday.
Say again. I didn't hear what somebody said. All right, you all are already doing this one, right? Is there any information in this drawing that is not necessary? Anything in this drawing not necessary? The correct answer is no, everything's necessary. So I gotta have the 8 plus the 5, and that becomes 13. Half of 13, 6.5, and then 6.5 times 6, and then that answer times the 12, right? So I need all of it. Would a musketeer walk us through the answer to this in just a minute? Which musketeer would help us out with this?
I'll do it.
Thank you.
I just realized I remuted myself directly after I said I'd do it. So.
Okay. Kimani or Lincoln or Izzy or when you guys want to help Graham out? Liam? Don't all rush at once. All right, Graham, go ahead.
So first plan here, in order to make the trapezoid equation work, the formula work, we have to do 5 plus 8, which is 13.
Yep.
And then we need to half that,
Wait,
which
why?
would be 6.5. Because
Why?
wait, we need to have. Oh,
Yeah, that's right, but why?
I think if you cut it a certain way. Wait, I feel like I'm thinking about this the wrong way.
No, you're not. You're right
If you
on.
cut it a certain way, it will fit into like a square or something.
You can make a rectangle or a parallelogram out of cutting it long ways. That's correct. That's why you have that number.
Yeah.
That's exactly right, because then it's only half as tall, right? That's correct. Okay, so 6.5 times 6. That 6 comes from the height of the original trapezoid. And what is 6.5 times 6? 39?
So that would be
39?
Yeah, 39. That's correct.
Okay. And
And
then what I do with that?
You multiply that by 12.
Okay. Why?
Because since we already did the halving, it's already in the shape it needs to be. So that way we just have to multiply it by the width to see how many slices we can put in there.
Correct. That's correct. All right, let me do this. So then we do the height, which would be 39 times 12. And then that equals the volume of the whole thing, which is 468.
Sorry, it's kind of a big mental problem to do.
468? Yeah, we're about to get cut off, so it's 468 cubic units, right? Okay, so again, tomorrow we will continue. Join me back in just a minute. This will cut off. I'll send the GimKit code out and join the Zoom back up. So see you guys in just a minute.
Bye, guys.
Okay. Bye.
Bye-bye.
Goodbye.
Aaron Frasher Nasher. Everybody knows him. Oh, wait. Can I have